Thank you for coming here today. Please welcome Bret Fisher, who is a Docker Captain. He's the author of the author of the Docker Mastery course on Udemy, and he's been deploying Docker and Node.js in production environments since before it was cool. He lives just a short walk from the ocean in Virginia Beach with his little puppy Whiskey, 5-month-old. And he's going to tell us today about best practices for using Node.js in Docker containers. And you can reach out to him on Twitter at Bret Fisher. And that's it.
Yeah, thank you. You're awake after lunch. It's awesome. All right. So basically, this is a best practices talk applied specifically to Node.js, things like NPM. So this session is for you if you know a little bit of Docker and don't consider yourself a Docker master yet, or a Docker ninja, and you know some Node. Obviously, if you're here, this is not a Node 101 talk, so this assumes that you've made at least some simple apps in Node. Most of you probably are doing Node in production if you're hanging out here, because this is not a Node conference. So thank you for being interested in Node. This is like a vintage old t-shirt I found, and I was very excited that I still had it. So basically, you want to put those two together to have the best Node experience for development, test, and production. That's really what we're trying to do here. So we're going to Dockerfile best practice. Yeah, that's kind of expected. We probably would do that. Then we're going to make a real-world multi-stage Dockerfile for Node that's much better than the typical blog entries you see on examples. And then we're going to build in some auditing and security scanning on top of that. We're going to talk a lot about proper node shutdown so that you make sure that your containers can be replaced in a zero-downtime type of situation. We're going to talk about HTTP connection management, because I imagine if you are using Node or just JavaScript in general, at some point you're dealing with HTTP servers that you're running. Now, obviously, Node can do lots of things, but we do a lot of web with it. So HTTP itself deserves its own consideration and to talk about connections and stuff like that. So let's start off real quick with the Node Dockerfile stuff. I'm not going to talk about Node Dockerfile best practices. I actually did that 2 years ago at DockerCon. So just search YouTube for Bret Fisher DockerCon, and you'll see like every year I build on the last year's talk, and I talk about best practices in Dockerfiles and best practices in production and all that stuff. So you can get all that. And I have links to all that stuff at the end on the last slide. So we'll get to that. All right, so this is every sample Dockerfile for Node that you've ever seen on a blog that's getting started, and it's garbage, right? Like, it works. It works. It works for your first day on your very first app that has 5 lines, right? But that's it. That's all this is going to do. So we are going to start with this, and we're going to keep iterating throughout the day as we're not here that long, throughout the few minutes that we have in here to get us to a relatively close to production solution, using all the latest features, except for the ones in the demo yesterday and today, because they don't let us captains know either, so we don't have the new stuff. So this is using 1809, last year's last stable release from the fall of 2018. Okay, so all just the stable, normal Docker stuff. All right. I was gonna do a bunch of crayon writing with my iPad. iPad, you can write on the slides now. I was all excited about that, and then I screwed it all up and had to delete it at the last minute. So, yay me! I can't even handle a keynote. So basically, 12 is out. Like, I don't know what happened, but DockerCon happened, made my slides outdated because I don't have all the latest commands. And then Node 12 came out, so all my stuff is in Node 10. 12 is the latest release of Node that is at least on the stable track. So it would be really cool if I had 12 in all my demos, right? So don't use the latest tag. That's sort of a PSA. You should know that at any level of Docker. Doesn't mean you can't use latest for just testing and playing around. But if you plan on going production at all with containers, you will never want to use that tag again, because it will give you whatever random version is the latest one that now is 12, and you're probably not ready for that. So some of the advice here, and we're going to get into from images, because one of your biggest concerns up front on every project I ever work in, whether it's Node or anything else, is what should we use as our base images? What should we use as our from in the Dockerfile? Obviously, Node has a official repo. Those are the ones I always recommend people start with. But you get choices there, and it's about the underlying distribution of an image that you can use. You can use Debian, which is the default, or you can use Alpine. That's also an option. There are other options as well, and I'm only going to be talking about official images, not third-party custom images, because I'm not convinced that we need those with Node in most situations, unless you're doing maybe custom builds or something. So Debian is what you do if you're migrating. And most of you, I imagine, I learned brownfield this week too. I didn't know that. Most of you are on brownfield apps. I'm still not convinced that's the right word we should be using. But we're not using greenfield, right? I mean, it's great if we can all start in containers and start an app on day one in containers, and that's great. But a lot of you are going to be migrating Node.js apps into containers, and that's a lot of the projects that I work on, is the migration, or as Docker puts it, the MTA, migrating traditional apps. So if you're not familiar with Debian or how Linux distributions work, all of the standard official images from Docker Hub run Debian underneath. Doesn't mean that they're running the kernel. It just means that it's giving you the apt-get package manager and those things that you would expect in a container. And it uses Jessie. It used to use Jessie. That was the older version. Now we're using Stretch. So if you start worrying about security scanning and making sure you have all the latest stuff, you're essentially going to want to focus on Stretch Linux version of Debian. This is a little deep, but if you're not into this stuff, eventually your security team will ask you about this, and you'll have to go look at the Dockerfile that Docker uses, and you have to figure out where it's built from and ensure the integrity of that. So my advice is to use Stretch, which is now the default. That's a good thing because it improves your security scanning results. And if you're not aware, we actually have it in the next slide. Maybe I have it. Okay, we'll talk about Alpine first, and then we'll talk about the actual sizes. So there's 3 different options in the main Node repo, and they are the default, then there is Slim, and then there is Alpine. Now, if you've been around the container community a while, you hear a lot of hype around Alpine, and a lot of it's true. It's really small. It's really tiny. It is focused on security, but it has drawbacks. And so it's not the thing that I recommend for most projects, especially if they're migrating in. So there's this Slim option with Node that gives you everything you need for Node without all the standard build tools for binaries. So if you're not building compiled libraries into your Node apps, which a lot aren't, then you don't need anything but Slim. And Slim is almost as tiny as Alpine, so you would not necessarily need to move to Alpine for space reasons. All right. To get a little bit more into the differences between these two, my link actually will have these slides, and I have an open source repo for all this stuff on GitHub. So again, the link will be at the end for you to check out this stuff later. But Alpine is a very popular base image that starts at 5 meg. It could almost fit on a floppy. And it's small and security focus is its focus, but it's not a traditional Linux distribution. So it doesn't have a lot of the things yet that traditional larger distributions like Ubuntu and Debian and Red Hat have. And so a couple years ago, Alpine was making all the news because it was 5 meg, and these other options were hundreds of megs or bigger. And it was definitely a good reason to save you some space on a server. But over time, a lot of those other images have all got smaller too. They've all taken out unnecessary tooling, unnecessary libraries and commands. And basically over time, if you look at the official images, they keep getting smaller and smaller and smaller because we're learning what we don't need in the container. We're learning that we maybe don't need IP configuration tools and stuff like that. And you can install those on your own. So the benefit of Alpine as a space savings is basically, in my opinion, nil. It's not a reason to do Alpine. If you want to do Alpine, you have to have other good reasons. Alpine, for example, is not without its own quirks. So last year, if you use NodeMon last year had an issue with file watching for development, but it was only on Alpine base images. So it was a way that Alpine uses different C libraries, and it was the way it was tracking something in the file system. So anyway, the point is that there is no panacea. There is no perfect base image. It's up to you. I always start with Slim, and we'll see that in a second. The other reason that I got to warn people about Alpine right now is that currently, if you want to do CV scanning of your images, which I think is great to do, it's easy to do, you'll see a demo today, Alpine doesn't work really with that. There is a database, it's a very small database that you can use, but it's complete if you're someone who's been in a shop that's scanned images like Red Hat and Ubuntu and Debian. So there's some great documentation on kubex.com. It's a website. I have a link in the slides if you want to look at it later on my website. Basically, there's a couple of great articles where someone analyzed all the different security scanners and looked at all the base images and gave a great pro-con spreadsheet example of all the different reasons why. Okay, so to get the point here, though, is just look at these different versions. So we're looking at version 12. Yay, I updated the slides, version 12 of Node. And you have Alpine there at 77 meg, and then the Slim is only 150 meg. So on a server, how much do we really care about 80 meg of space? Like that's, assuming that everything's running the same image, base image, right, which is probably not true on every server. So let's double that, triple that maybe, and now we're talking about a couple hundred meg if I don't use Alpine. As a server admin, that is not a factor to me. If I don't have that much free space, I'm already in trouble. So I don't make decisions based on size. I have to have real good reasons. And for most developers, we're all used to apt-get and that Debian, Ubuntu experience, so stick with the default. Stick with either default or the Slim. You can see how crazy big, though, the default 12 images in the middle. It's 900. That's because of all the build tools that come with that standard base. It's not Node. It's actually just the base underlying stuff. And then Node itself, I think, comes with more tools in order to also use the building tools like we're going to mention here, Node GYP. So Node modules is a thing when you first start developing in Node, you're going to run into issues with your host where you're probably used to developing on your host and you want to start developing in containers. You're going to have Node modules on your host because you're used to that. But then there's a struggle of what do I do in the container? Do I link it to the host with a bind mount? Do I put it in the, copy them in the container and leave them in the container? Like, what do I do there? So you don't want to use the ones from your host on your development machine unless you're a Linux developer. If you have Linux as your main machine you develop on, congratulations, you don't have any of these issues, you can go home. The rest of us on Windows and Mac, we're not running the same architecture on that main OS as in the container. So if I have any actual binaries in my app, and maybe your Node app is pure JavaScript, and all your modules are pure JavaScript, and good for you, but some of you will probably have like image magic. If you wanted to manipulate images, that's a binary, and so that's not going to work across architecture. So the first time you try to do a Docker Compose up, it might, a sample file that you get off the internet might automatically connect your Node modules in, and then it wouldn't run because it's for Mac, not for Linux. So this is one of the core issues that get people stuck. And one of the simple ways to solve that problem is adding the Node modules to your Docker ignore to make sure that first it never goes into your image. You want your image to do the npm install. You don't want your Node modules from the host. So that's sort of step one. If you're not aware of the Docker ignore, it's just like the git ignore file. And you want that basically in every single app. And you definitely want it to keep .git out, right? You don't want to put .git in your containers. You don't want to put Node modules in your containers. Obviously, anything like tests or logs, you usually want to keep those out too. So I tend to just copy the git ignore and make a Docker ignore out of it, and then away we go. The next thing in Docker files, this is security related, is that you want to enable the Node user. So every official Node image comes with a Node Linux user out of the box. It's not enabled. And the reason I think it's not enabled, and I don't know this for a fact, but I believe the reason it's not enabled is because it makes it harder to do things. You're not root in the container, so things like npm install might not work depending on how you have it set up. So they don't enable it, they just provide it, which I kind of wish they would put that up at the top of the documentation, like, please take some time, do least privilege. It's a good thing. So all you have to do is add user node into your Docker files, and now the Node app in your container is running in the container as a non-root user, which means if your app got hacked in the container, obviously the goal is that they can't break out of the container, but if they're just using the Node process, they're not even root in the container. So they can't even do bad things in one container, right? So you want to do that, and it's easy to do. It just has a couple of complexities with it. So you want to order it so that it's after any root required things like APK, like that's for Alpine, or apt-get commands, or if you do npm install global, which requires root in Linux by default. And then you're going to do it before your standard npm installs of your app. So you're kind of sliding it in there in the middle. Because the minute you type node, user node into a Docker file, then the following run commands will all run as that user. Okay? And it also may cause some permissions, and we'll get around that in a minute with an example. So you would just use, in that case, chown to change the permissions. And let's look at this example. So remember this silly blog example, Docker 101 for Node users? Well, so look at the top right. That's the name of this Docker file. So as we progress through this file, it'll change numbers. So now we've added a few things. So let's see if this works. Yeah, so we've added this manual run line to make sure we get permissions in our app directory. We've added a chown down here. So during the copy command, we're changing the permissions of the files, including the package file and when I copy all the source code. All right? So that's the first thing, is we're dealing with permissions and enabling least privilege. So now let's talk about shutting down your application. And this is a big one for Node because out of the box, the experience sucks. It's similar to Python and other scripting languages that don't handle Linux signals by default, so you have to do something. You have basically 3 choices or your app will suck, basically. So it'll suck when you replace it. It'll run fine, but when you want to replace it and you're trying to go for low downtime, you're going to have some real issues. So in a container, the nice thing is we don't need other process managers for Node, right? The whole design of containers is around being able to spin up many containers from one image, regardless of what technology you're using to do that. So you don't need PM2, Forever, NodeMon. You don't need those on your servers. Now, we will use NodeMon in a minute for local development. That's still a thing you want to use for cycling Node every time you save files. That's still a thing. But you're not going to need those other things. In fact, we don't even want to run our apps with NPM. NPM start, I think, is an anti-pattern in a container. So we want to let Docker control the node process directly as much as possible. We want Docker to spin up one node, and if it needs to run more instances because of threading, then we would spin up many replicas, depending on whether you're using Kubernetes or Swarm or ECS or whatever. You would spin up more containers. That's how you scale with Node, not with Node tools, all right? So with Node and NPM out of the box, they don't listen to the shutdown signals in Linux. So we got to fix that. And this leads to my next problem that the internet gets wrong, I think, a lot of the time. And I'm here to try to set the record straight a little bit, that Node handles signals as well as anything else as long as you tell it to. It does not necessarily need something in front of it to manage signals if you know what you're doing. And that's why we're all here. So basically, a process in Linux, and it's very similar to Windows, it needs something that starts it. We call that init, right? And that manages its life cycle. And there's a couple of main things that it needs to do. One is to reap zombies. And zombies are essentially sub-processes that lose their parent. And they're out there all alone. And they need something to manage and reap them, basically get them and take care of them. And the other thing it needs to do is pass signals to sub-processes when necessary. Unfortunately, NPM does not do that at all. And Node doesn't do it by default. So zombies are not really an issue in Node. We don't spin up a lot of sub-processes in Node that are separated, and even when we do, they tend to be handled really well. So even just spending an hour Googling for people trying to have this problem, I don't really see anyone. They talk about it, and they just ask, and then people say, no, I've never had that problem. So I have not experienced it with my production workloads, and I've worked on ones that are worldwide, global solutions. So not the biggest of the biggest, but I feel like I've got enough experience to say that I don't think it's an issue. The second thing here is proper node shutdown, which is super key in your apps. And the way you know that, by the way, is if you just do a Docker run on your app, and then when you ctrl-c or you do a Docker stop, if it takes 10 seconds to shut down, you have a problem. That means that your app is not listening to signals, and it's waiting for Docker to kill it. Because Docker waits 10 seconds and then kills apps. Kubernetes, I think, waits 30 seconds. So Kubernetes would even be a longer wait time, and then it would just kill your app because your app's not listening for signals. So there's these things in Linux called signals. The ones we really care about are the first two, sigint and sigterm. And they're standard Linux concepts that are easy to grab in Node and use for your whatever you want to do. So basically, when you tell Docker to stop a container, or Docker decides to stop a container because it's unhealthy, similar to Kubernetes, they send the signals, specifically sigterm. They send that signal to the container, and the container is expected to know that, receive it, and then shut down accordingly. Like if it's a database, it's going to write files to disk. You know, if it's a web app, maybe it's just going to send a fin packet to signals on the connections to tell the connections, hey, I'm terminating, please reestablish connection, and then the load balancer is supposed to do all that for you, assuming you have magical orchestration. So those are all things that have to happen, but NPM doesn't do it, and as far as I can tell, they're not going to do it. The last I checked, they hadn't done any work on it. So that's why I feel like NPM should not be your initializer in a container, because it doesn't want to deal with this. Node can do it, but you have to add some code, or put another process in front of Node instead of NPM. All right, and so I'm going to show you 3 options. The temporary option, and probably some of you know of this one, is when you're doing Docker run, is to add --init. It's a really great way to run someone else's Node app and add in initializers so that you can ctrl-c out, or you can Docker stop, and it'll work. All right. Docker provides this thing called Teeny out of the box. It's another open source tool that they bundle with Docker that you can elect to use on any app at any time by just adding docker run --init. And it basically shims the startup of the container with this thing, Teeny, that acts like the zombie reaping signal processing thing that we need. All right. It's a temporary solution. It's not really something you use in a permanent app. If you are not allowed to touch your code, which I believe most of you probably can edit your Node code, but if you're in a situation where you're only allowed to run the app given you, and you are not allowed to change the source code, then what you would do is add Teeny to your images, and then basically you would still use Teeny, but you hard code it into your app so that your app does it every time. And the first solution isn't needed, okay? The last option, and my favorite option, is to put in production code, or put in code that will work in production and work everywhere for capturing those signals and then properly exiting your app like we all want to do. Even stateless apps need healthy shutdown, right? All right, so this is how it would look if you did a Docker run with the first option, the temp option. This is how it would look if you were going to add Teeny into your, this is actually an Alpine example of adding Teeny into your app. The Teeny website or GitHub repo has all the different examples. And this is taking our last Dockerfile, Dockerfile 1, and now we're getting even more stuff into it. So we're adding the Teeny up top, right? We're changing the entry point. Entry point runs right before CMD. The entry point and CMDs come together. So we're technically running the entry point, Teeny, and then it runs the node command down here. So you see that I've changed this from npm to node. So we're not executing npm in the image. All right, and so if you're interested in the actual code stuff, this is an example of how you can take, this is what if I used Express or just a standard HTTP server, and I just simply needed to capture the signals and then properly shut down the HTTP server. There's another example here in a minute that's a little better than this one, but this is the minimum information. So I basically cut and paste this into every Node app, wherever you're going to have your startup JS, and however you're going to start up your image, whether it's in the bin/www or wherever you want to put it. And then you just basically are doing this key little server close command on the HTTP. So the idea here is that you're telling the website to stop, and then you're exiting the process healthily. That's not even a word. I just made that up. This is the better one. And I wasn't going to show the code because it's a whole repo. Stoppable is pretty great because what it does is it tracks web connections and properly controls each connection every time by sending them a fin packet to basically tells the client connection, please reestablish connection, and hopefully your load balancer knows that your Docker container shutting down and will direct them somewhere else. This is the only way I know of to have true zero downtime deployments in Node, and with any language really, is that you have to be able to track connections in web, be able to handle those connections so that you're not severing them all by just stopping the process. Obviously we have web browsers that are pretty resilient, and probably if it's a static website, you'll be fine. But if you're trying to deal with long polling connections and you're worried about data and people maybe uploading files, you basically combine this with health checks and long shutdown times so that you exceed the window of long polling, and you eventually get to near zero or zero downtime deployments. But this is the first step in Node, is to try that out, stoppable. All right. Multi-stage builds have been around a couple of years, so I don't want to really go into exactly what that is, but it allows you to essentially save. You can have multiple concerns in the same Docker file. So you can build in your dev dependencies and your production dependencies and your testing frameworks all into a single Docker file. So one of the problems with Node is that we want, like every language, we want to avoid having our test and our dev dependencies in the production images, but we do want that stuff locally for dev, and then when we do CI, we want that in our CI as well. So basically, we're going to make different stages in the Dockerfile, and we'll get to that. We'll show that in a second. And if you can optionally use the newer command npm CI, which guarantees it uses the lock file only. It's a little more robust in terms of using the lock file and not the package JSON. But it's a little tiny faster. It's not, in Docker, it's not really much faster because it doesn't reuse the cache. But and make sure that you've got your production dev environment set. So this was the one you just saw. This was the Dockerfile we just had. And now we're getting more complex. This is a multi-stage. So I have stage 1 up at the top. Notice the from image up there. And then I have this from image down here that is taking that and turning into a new image and adding some development stuff, like adding my development dependencies, setting it to NodeMon so that I use NodeMon locally on my machine for dev. That's simple. Now we're going to get more complex. So you might build this image this way. So if you just build a standard build command, it will build the whole Dockerfile, and whatever's last will be what your result is. But you can target specific stages with the Docker build command. And you probably saw some of that. They actually did that in a demo today in the keynote. They targeted a different stage. So I can target the production stage only, and it won't add the dev dependencies. So I might do that in CI right before I push the image up into my registry for production. All right? And you also can add another stage, and you can just keep adding stages. Stages for test, for security scanning. So let's keep doing that. One of the things for dev is you don't actually, oops, I went a little fast on that one. You don't actually need to copy code into the dev image or to the dev stage, because in dev, you're going to bind mount your code. On your local machine, you're just bind mounting your host code, right? So you don't need to also have the source code in the image. It's irrelevant because it's just going to use the host. So you can save that step. And then you can also, one of the other goals is to keep it dry, never repeat yourself. So that's what we get to this. So it's getting a little harder to read. And we now have this is the standard base image that just has all the defaults. We're just installing production packages. None of that changed. Then this didn't change. This is our dev image. It stayed the same. Now we're creating another image that's just pulling in the source code. And then we're taking that source code and combining it with the dev dependencies. That's what this little copy line here does. We're combining the source code with the production and the dev dependencies and doing stuff like linting, npm tests, and all that in a test. And then finally, we have a prod image that does not have the dev dependencies. The reason that I'm breaking all this out is that what I don't want to do is copy stuff in, test it all, and then start from scratch and build the production, right? What I really want is to test, be as close as possible to testing what's going to be in production. So we essentially build what's going to be in production first, do all the dev and test stuff, and then we go back to the original source as where we're starting from because we know we've tested it. So essentially, this is like free CI. Hopefully you're not with a CI vendor in here, because if you don't have CI today and you just want to use Docker Hub and GitHub, you can do this, and it's testing every one of your builds with whatever test commands you put in that test stage, right? In fact, we can go a step further. Oh, I should have done that, sorry. Bigger. So we can also add more in there and just keep adding stages. All right, so I'm going to add another stage. I'm going to add npm audit, which is a good thing to run. And then I'm going to run a CVE scanner, which scans for known vulnerabilities in my app's dependencies. Not necessarily, it's not a code scanner, it's a dependency scanner to look for known Linux vulnerabilities, Node vulnerabilities, npm vulnerabilities, anything like that. So it's going to take that image, and then it's going to add more stages down below. And so now I have this audit one, and the audit one depends on the test one. So if I try to build and I target this stage, it will first build this one, right? So the dependency order matters. And it will then come down here. You notice it actually changes the user back to root because I need to be root to do these things. And then I do an npm audit, and I actually set the audit level to critical so that, because there's always something. In npm audit, there's always something, it seems like. So I don't want things that aren't critical to fail my build, because that's what these will do. Every one of these commands will exit one or exit with an error and give you a failed build if they don't pass. So my advice is when you start is you always make the scans just do the little as possible. They won't fail for something. So that's what you could do there. The other thing I do here is from Aqua Security. They have a scanner that scans CVE inside your Docker image when you're building it. So this is basically, I just add a token at runtime. And they have an open source scanner on their website that uses their CVE. And there's other options. There's 3 or 4 other options. Some scan from outside the image. Some scan in the image. It's just depending on the scanner. It's like antivirus scanners. They all report slightly different results. So you might have multiple stages if you're super security conscious, and each stage is a different security scanner, and then you combine them together, and then somebody decides if that's acceptable. So, all right, let's jump to Compose real quick. We got about 10 minutes left. By the way, for questions, I'm just going to hang out in the hallway afterwards, because I won't have time for questions. All right, here's another myth buster. Version 2 and version 3 of Compose are still legitimate versions. Version 2 was not replaced by version 3. It's an unfortunate effect that we called it version 3, and then everybody thought version 2 was outdated. Version 2 is designed for local dev and test, and it keeps getting new features. In fact, the latest feature, I think, was late last year. If you're not, basically the rule is if you're not using Swarm or Kubernetes with these YAML files, keep it in version 2. Version 2, oops, sorry, I'll back that up. Version 2 is ideal for local dev and test. Version 3 is designed for not just production on Kubernetes or Swarm, but also if you need to use the file with both dev and Docker Compose command line and Swarm and Compose. So the version 3 works on both sides, but it has to give up a few things that are local dev-only concerns, like this next example. So this is every Compose example you've ever seen on the internet of Node, right? And so let's first talk about, we're going to build that up real quick and make it more advanced as well. The problem is we can't just bind mount with the Node modules, right? Because we have that whole incompatibility. So the 2 potential solutions that I recommend, solution 1 is what most people use, and that is just to bind mount your app in the container to your host. And what that means is that until you do a Docker Compose run npm install in the container to then write those files to the host, you can't technically do a Docker Compose up. So it's a little hard if you've never actually had this problem or to conceptualize it. But basically, if you have your Node modules on the host and it's incompatible with the Linux in your container, then you can't ever run npm install on the host. You only can run it in Linux unless your host is Linux. Because if I run it on my Mac, those are going to be Mac-based dependencies. And so I have to run them in the container. So this is easy to get started. It has that middle requirement that you always have to do Docker Compose up, or Docker Compose run npm install to install your Node modules before you can run the app. All right? And so the other thing there is you can never npm install from host, because then that'll get you Mac or Windows dependencies, not Linux. All right, so solution 2 is sometimes better, sometimes not. Solution 2 is where there's a feature in Node modules and just Node in general, or JavaScript in general, where you can, what can I say? Node will look for Node modules up the path. So if it doesn't see a Node modules in your current directory, it will look up a directory, and so on, until it gets to the root of the file system. And it'll unfortunately use the first one it comes to. You can't actually hard code it that I'm aware of to tell it which one you want. And it doesn't like mash them all together. It basically just uses one. So what I would do here is I would move Node modules up a directory in my container, and then basically bind mount and make an empty volume in the app directory itself in the container. And that way my app won't see the one from the host. It will only use the Node modules that are up a directory in the container. I know this is I wish I had a better graphic to show you. But I have examples on all this in the links at the end of the slide. And that way, the Node modules on your host is separated. So they can live separate, which means you could do development on the host without Docker, and then you could do it in the container, and the Node modules would never clash. All right? So that's a little more advanced. I call that solution 2. I don't really have a good name for it. But a lot of my students in my courses prefer this option simply so that because they maybe don't always want to develop in containers, and so they like having the flexibility. It just requires that in their container. Not every app works with this. There are some unfortunate, frameworks out there I think Express does work and Happy works. There's some other ones out there that don't work with the node modules up a directory for some reason. They don't follow that standard, or their app's so fancy that it doesn't work. So not every app works with Solution 2 if you're using a lot of frameworks. All right. Bind mounting performance, in case you didn't know a thing, if you're in large projects with Node, if you're on Windows, I'm sorry, it's slow. I can't help you. It sucks. So I'm talking very large projects, right? Thousands of files, big NPM installs. So the two things you want to focus on is making sure that your NPM install is not something that you have to run constantly, because you really just never want to run it. So that's how you design your Docker files properly, like I showed you, so that you won't have to run npm install unless you change the package file. And then the other thing is, if you're on Mac, make sure that every one of your bind mounts has delegated. Always, always, always has this little option at the end called delegated. And on Mac, that will make your performance much, much faster. It actually disables the write guarantees on that link and ensures that the Mac basically serves up the files in an asynchronous manner. And so when changes happen, it doesn't have to wait for them, essentially. So this is our simple little file, right? And then we're going to add, so notice how I've added the volume here. It says delegated on the end, so it works on a Mac. On Windows, it'll just ignore this option because Windows doesn't yet have this support for the whatever, I can't remember the feature that they call for this, but Docker has documented it in their website and blog articles and stuff. So if you just search like macOS dedicate or delegated file sync or something, you'll find the Docker documentation on it. All right, so we have this, right? And we're going to keep going. So notice that I've targeted my build in my compose file to target dev. So that dev stage with all my dev dependencies, that's the one my compose file is going to build and use on my local machine. So that's how you use multi-stage with compose, so that compose only uses the dev image, not the production image, right? So you're going to use NodeMon. I think we mentioned that, right? If you're using something besides NodeMon, these all basically work the same. And if you're on Windows, you need to make sure that whatever you're doing in Docker, no matter what application you're using, you need to enable polling in the file system, because Docker on Windows has the unfortunate side effect of it's a cross OS and a cross file system communication, so there's no parity there like there is on Mac. So there's no way for the Linux VM to know when you change a file on the host. There's no file I/O syncing. It works on Mac and it works on Linux. Does not work on Windows. So what I do is I add all the things I need, all the other stuff I need to compile and build, like TypeScript and all that stuff. It all ends up going in my NodeMon JSON, and then every time NodeMon sees a change using the polling method, it automatically restarts the container, right? Or it restarts Node. It doesn't actually restart the container, right? It just restarts Node inside that container. All right. So let's talk a little bit about startup order and dependencies. The problem here is that if you're on development, this is actually mostly a development problem. Is that my laptop? my Slack, and I can't mute. There's no way to mute. So you get to hear my Slack messages. Dependency awareness here is where we had the depends on. Now, who here has tried to use depends on in their Docker Compose file, and it doesn't do what you wish it would do, and you're all mad? The solution exists, you just didn't know it. It's already there. It's not a wait for script. It's none of that garbage. It is simply using the version 2 of Compose file with depends on and a health check. If you have those three things on, it all works. This is just for development. This is not a production concern. But it all works like you would expect. And the way we do that is, this is the Compose file we just had. Now what I've done is I've added depends on my Node app. I have a database. I have a Node app. I've added depends on. I've specified the dependency, what has to start first. And then I've added a condition service healthy. That has to be there, condition service healthy. And then whatever my app is I'm depending on, I have to give it a test, a health check that will pass. And Docker on GitHub has released health check examples for every major storage system. So like Postgres, MySQL, Mongo, Redis, they all have examples health checks there that you can go find. Just search Docker library health check. And then you'll find all these examples. You can add this in your Compose files, and if I had time to show you a demo, it would work. I would type Docker Compose up, and it would even try to start my Node app, and it would realize that the database isn't responding to queries yet, and so it would sit there and wait until the database is ready 10 seconds later, and then it would spin up my Node image. And you can have multiple levels of that. All right. So the production checklist here is essentially doing the key things that are going to affect your startup and your shutdown of your apps, right? So we're making sure we're using Node directly as a CMD in our Dockerfile. We're making sure we add the Docker ignore so that we don't get the stuff we don't want. We're properly capturing the SIG term. We're throwing in the production npm option so we only get our production dependencies, not our dev dependencies. And then we're adding to our CI solution or wherever we're building our images, we're adding the scan audit test that we get sort of almost with just a couple of lines of Dockerfile, but it's almost free for you to do that. Even if you're not doing actual code testing yet, you can still do npm audit and use a CVE scanner like that out of the box. And then lastly, the health checks. So you just saw a quick little example of health checks, but every app you ship has to have health checks. If it's in anything containers, you cannot do distributed computing or orchestration without health checks, or you will just have downtime. Like, now maybe you're lucky and you have a shop where you can do that. You can just say, I have a 4-hour window for downtime, so I'm just going to take down all my apps and have a coffee, and then I'm going to bring them up again. But the rest of us have to have as close to zero downtime as possible. The only way you're going to get there is through health checks. I could do a whole talk on health checks. So enough of the soapbox. Thank you so much for coming. I have new courses out. This is not meant to be an advertisement for my Node.js course, but I do have a Docker for Node.js course that launched last week. So there's 9 hours of me talking about all this stuff in there. And of course, I'm online every Thursday on YouTube Live with other Docker captains. And so if you just search YouTube for Bret Fisher, hopefully you'll find my channel. All of the links for everything I talked about here, including the open source of these example files, is all at that URL. And thank you for coming.